This is the second types. This is the second questions, and the question came directly from the homework on the hub. So as you can see that I also have my picture drawn already, but there's nothing in it. So with this picture that you have no points. So you're gonna have to actually apply the free body diagram to figure out how many forces there are acting in the system. And then you will utilize the equation which is F equal ma, which is the sum of the forces equal to the mass times acceleration, since it is at equilibrium, which means that all the forces are balancing out, which means there's no movement in the x or the y direction. That's why I have it there. So you're gonna go ahead and draw the add on to the free body diagram. So if I were to be you, I'm also gonna be looking at the question right here. It says examine the diagram to the left, which is this one, by the way. What force F is required to keep the 60 kilograms mass in static equilibrium? So basically, static equilibrium means that the object are in place, they're not moving. So it says right there that the mass is equal to 60 kilograms. So basically, it kind of gives you the hint already. So if there's a mass, there also going to be a force due to gravity. This one right here. And also, the string is actually attached to the ceiling with a certain incline. With a certain angle. So they give you this angle right here, which is 40. So for me, I'm gonna go ahead and take the angle into the consideration right here. So since the tension is pulling that way, so I'm adding two different forces in x and the y directions. This is what you should be doing every time, x and the y direction, and this force become unreal because we actually break into the x and y component. And the angle right here is also 40 because the angle is the same thing as that angle when you learn your geometry, I guess. And that will also be the force of tension, always cosine theta. That's what we've learned from those tricks, and this is sine theta right here. So if you do this one right here, you will get at least 4 points for the free body diagram. And the other points will come directly from applying the sigma F equal ma for both x and y directions. So I'm just gonna go ahead and put this one right here. You have a reference over here on the side, just to see if we get that. So our ultimate goal is to be able to draw a free body diagram. This is all represent other forces, and also be able to utilize the concept of net law of motion, which is the forces to calculate the force of tension and the weight for the very specific situations. So for this one, I want to go ahead and take the x direction into consideration first. So for this one, how many forces are there for the x directions? 1 or 2, 2 or 3, 3 or 4? The answer is 2. 2 different forces, 2 different directions. So you're going to go ahead and add them up. There, t sine theta, but we have the angle already, so that's it. So now we can, once we start adding on the forces, we want to be able to go ahead and assign the sign of the forces. If it is going to the left, it's negative. That's why I put negative there to begin. And force is to the right. So with this conclusion, we want to figure out what F is. At this point, we need to kind of add t sine 40 on both sides of the equation, and that will give me this one, t sine 40. So what this equation actually is telling you is that the force over here to the right must be equal to the force on the one on the right, on the left, which is represented by t sine theta. So we not only that we take the tension force into the force of tension into consideration, we also take the angle into consideration as well. So you know this one, but since we don't know t, we can't really looking for F. You have two unknowns. You can't do that one yet. That's why I have to figure out what are the forces in the y direction, just for me to plug in other values. So in the y direction, I have also 2 different forces two different directions. So I'm just going to go ahead and write it down. At mg equal to 0. That's what it is. We're trying to look for t right here. Do we know mg? Yes, we do know mg. That's the mass times the gravity. And we use the 9.8 as the gravity. So at this point, I'm just going to go ahead and try to rearrange the equation in such a way that I will solve for t. So the first thing that comes to my mind is that once I have that minus right here, mg, I'll just go ahead and add both sides of the equation. So once I do it, I'll get t cosine 40, because right now you know what the angle is, equal to mg. And then in order for me to look for t by itself, I'm just going to go ahead and divide mg by cosine of 40, and that should give me the answer, which is the force of tensions. So mass is this multiplied by 9.8, which is the force due to the gravity, and then I'll just do this divided by cosine of 40, and that should give me the answer. So on your calculator, you would go ahead and do 60 times 9.8, press enter, and that should give you about 588, and now you do division, divide by this. Divide by cosine 40. At this point, you may want to double check your calculation or at least attempting to do so. The answer is supposed to be 767. Then once you get the answer from the force of tension, then I will substitute this one over here to get the actual force that they want in order to hit that ball in system. 767 cosine 40. That should give me the answer, which is the force I'm looking for. So on the calculator, I will just go ahead and do 767 sine 40. That should give me the answer, which is 493. So as I can see, that in order for me to solve for this one, I must utilize both the forces in the x and the y direction. Because I just can't just solve for this one because I don't know what t is until I use the y direction to solve for t from the given information. So you always think about what's given and what can you do with the given information in order for you to solve for the required information. Go ahead. And have you looked at the example? So for one of the tests, if they just ask you to derive the equation, then you would want to look only the word on your left, because that's how you would do it. But if they ask you to solve for the values, then you must try to attempt to show all the rules just like what it is shown on the right side of the equation. On the board.